This video contains the solutions to sample exam number 1. So for this first question, we have 2 points and we want to know what vector represents the vector from P to Q. And so the idea is that when we have the vector from P to Q, all we're going to do is we're going to subtract the corresponding components of Q minus the coordinate of P. So this is going to be 0 minus 3, 4 minus 1, and then 1 minus 6. So that'll be negative 3, positive 5, and negative 5. And that's the vector we want. For this next one, we've got a parametric curve, and we want to find the slope of the tangent line. For this one, we have to remember the formula that dy dx, the slope of the tangent line, is dy dt, in other words y prime, divided by dx dt. So this is going to be the derivative of y, which is 2t minus 1, divided by the derivative of x, which is 4. We plug in t equals 3. That gives us 2 times 3 minus 1 divided by 4. That's 5/4. For this one, we have a point in polar coordinates, and we want to convert it to rectangular coordinates. Since it's a nice angle here, pi over 2, we can actually do this without needing to use any conversion formulas or trig, just thinking about how polar coordinates work. Pi over 2 is 90 degrees, and remember we always rotate counterclockwise from the positive x-axis. So this point is 5 units out from the origin along the ray where theta equals pi over 2, so the point is right there. And in rectangular coordinates, that's the point on the y-axis, 0, 5. For this one, we're converting in the other direction. We're given a point in rectangular coordinates, and we're given 4 points in polar coordinates, and we're told that one of these does not describe this rectangular point. So we can use process of elimination here. We don't have to be a particularly accurate plotter to figure out where this point is. Negative 4, 4/3, that's over here in quadrant 2, so it's right around there. So if we look at point A, 2 pi over 3, well that's 2/3 of pi. Pi is 180 degrees, so that's going to be 120 degrees, which works out. If we rotate 120 degrees and then go 8 units out, that gets us roughly to where we expected. So A looks like it does match the point that we're given. For B, we have 8, negative 4/3. So negative 4/3, that's going to be a clockwise rotation of 240 degrees. And again, that's going to get us to the point we want, so B looks like it works. C is negative 8, 5 pi over 3. 5 pi over 3 is 300 degrees rotated counterclockwise. That's going to get us around to there. But now, instead of going out away from the origin along that ray, we go backwards 8 units. And again, that's going to get us to our point that we expect. Finally, D, negative pi over 3, that's a clockwise rotation of 60 degrees. But since we go out from the origin along that ray, that's going to get us down to this point here. So that's the point that D represents, and so D is the one that does not describe that point. So D is the answer here. Now in this problem, you're given 4 different formulas, only one of which is the actual formula for the slope of a tangent line to a polar curve. So you can either have that formula memorized, or in a pinch you can rederive it. So the way that we derived that formula is we remembered that dy dx for a parametric curve, in this case if we parameterize with respect to theta, we would get dy d theta divided by dx d theta. And so how did we parameterize this curve? Well, we know that x is r cosine theta, and y is r sine theta. That's f of theta cosine theta, and f of theta sine theta. So now using the product rule, dx d theta is the derivative of the first function, f prime, times cosine, plus the first function, f of theta, times the derivative of the second function, negative sine, and dy d theta was the derivative of the first function, f prime of theta, times the second function, sine of theta, plus the first function times the derivative of the second. And then that is going to give us our formula here, which is f prime of theta cosine theta minus f of theta sine theta, all divided by f prime of theta sine theta plus f of theta cosine theta. This next question is another one that's testing whether you remember a formula. So when we talk about a vector valued function and we refer to speed, well, we need to remember that the velocity is the derivative, r prime of t, that's velocity. And then the magnitude of velocity, the magnitude of r prime of t, that's the speed. So So that's just really a memory question. Now for this one, we have 4 different representations of vector-valued functions that represent lines, and we want to know which one passes through the point 3, 4, 5 and points in the direction 7, 8, 9. So the way that we do this is when we have a line, is that r of t is going to be the initial vector r0 plus t times v, where v is the direction vector. So r0 is the initial point that they give us, 3, 4, 5, and then v is the direction vector, 7, 8, 9. And when we put that all together, we get 3 plus 7t, 4 plus 8t, and then 5 plus 9t, and that's option A. For these next few problems, we've got this diagram and we're just asked to match up the vector that we're looking for with the vector that we're being asked about. So u is the vector from p to q, and that's going to be the same vector as the vector from r to s. Remember that the position of the vector doesn't matter, only the direction and the length, and so that's option C. For u plus v, we can think of the triangle rule, which would be to attach v to the end of u, remember that's the same as v, and then draw a triangle from the tail of u to the head of v. Or we can think of the parallelogram rule, which is also the picture that I've drawn here. Either way, we get the vector ps, which is this option here. Finally, we're asked about u minus v. And the way that I like to think about this is that if I take u minus v and add v, what I get is u. So u minus v is the thing that must be added to v to get u. And in the picture, that's going to be this vector, because when I take that blue vector that I've just drawn and add it to v by the triangle rule, I'm going to get u. And so that's option D, vector rq. All right, these next two problems have us doing some vector operations. So we've got u is 3, negative 1, 5, and v is 0, 6, 4. And the dot product just says you multiply each component by the corresponding component of the other vector. So 3 times 0 plus negative 1 times 6 plus 5 times 4. That's going to be 0 minus 6 plus 20. That's 14. For the cross product, we set up our 3 by 3 determinant. So we've got I, j, k. We write the first vector in the second row and the second vector in the third row. That's going to be the determinant 1, negative 1, 5, 6, 4 times I minus the determinant 3, 5, 0, 4 times j plus the determinant 3, negative 1, 0, 6 times k. So this is minus 1 times 4 minus 5 times 6 I minus 3 times 4 minus 5 times 0 j, and then plus 3 times 6 minus negative 1 times 0 k. Negative 1 times 4 minus 5 times 6, that's negative 34 I. 3 times 4 is 12, so that's minus 12 j. And then finally plus 18 k. And we can leave it in ijk format, or if we like, we can rewrite it in component form, negative 34, negative 12, 18. Either one of those is okay. Now we want to find the projection onto v of u. And the formula we want is that it's u dot v divided by v dot v times the vector v. So u dot v, we already figured out, was 14. V dot v is just going to be the sum of the squares of the components of v. So 0 squared plus 6 squared plus 4 squared. That's 36 plus 16, which is 52. So this is going to be 14 over 52 times v. That reduces to 7 over 26, and v is 0, 6, 4. So that's 0, 726 times 6, 726 times 4. And again, we can simplify this a little bit. 0, 7 times 6 over 26, that's 42 over 26, which reduces to 21 over 13. And 7 over 26 times 4 is going to reduce to 14 over 13. And so that is our projection. Now we want to find the angle between u and v if they're placed tail to tail. And so there's a couple different ways we could do this, but probably the easiest way to do it is to use the fact that u dot v is the magnitude of u times the magnitude of v times the cosine of theta. We know that u dot v is 14. Magnitude of u and v we can figure out. So the magnitude of u is the square root of 3 squared plus negative 1 squared plus 5 squared. That works out to be the square root of 35. Magnitude of v is the square root of 0 squared plus 6 squared plus 4 squared. That works out to be 52. So this is the square root of 35 times the square root of 52 times the cosine of theta. Using our calculator, we divide both sides by the square root of 35 and the square root of 52, we get that the cosine of theta is 0.328165. Taking the inverse cosine of both sides gives us that theta is the inverse cosine of 0.328165, and that gets us 1.23644. Now we're asked to round our answer to the nearest degree, which means we need to convert this answer to degrees, right? That answer that we just got is radians. As always, when we use trig and inverse trig functions, everything's measured in radians. But if we're asked to find this in terms of degrees, then we need to multiply by 180 divided by pi, which works out to be 70.8426. And rounded to the nearest degree, that's 71 degrees. All right, here we're given a region in polar coordinates, and we're asked to have set up but not evaluate an integral to compute the area of that region. So this is a region between two curves, and so the formula we're going to be using is that it's the integral from alpha to beta of 1/2 of f of theta squared minus g of theta squared d theta, where f of theta is the outer function and g of theta is the inner function. And as we rotate around, and we're drawing our little radial lines here, the inner function is clearly the dotted curve, and the outer function is the solid curve. So that means that I almost have all the information that I need to set this integral up already. The outer curve is the circle, the square root of 3 times the sine of theta, and the inner curve is the dashed line, which is 1 minus cosine theta squared. So the only thing we don't know here are the bounds on my integral. Well, again, if I start rotating from the positive x-axis, I can see that the region starts right away at theta equals 0. And then the region ends at this point here where the two curves cross. So what does theta equal at that point? Well, one way that we can figure this out is by simply using guess and check. From the picture, it looks like that angle, or at least the angle that we have formed with the negative x-axis, might be about 60 degrees, which means the angle that we would be looking for, this angle here, would be 120 degrees, namely 2 pi over 3. So let's check it out. What do these two functions equal at 2 pi over 3? So what's 1 minus the cosine of 2 pi over 3? And what's square root of 3 times the sine of 2 pi over 3? Well, the cosine of 2 pi over 3 is negative 1/2, so this is 1 minus negative 1/2, which is 3/2. And the sine of 2 pi over 3 is the square root of 3 over 2, and when I multiply that together, again I get 3/2. So our guess worked, and the angle that we're looking for up here is 2 pi over 3. For this one, we're given a vector-valued function and asked to find a formula for r prime. And so all we need to do is take the derivative in each component. The derivative of 5t squared is 10t, the derivative of 4t squared is 8t, and the derivative of 3t squared is 6t. Now we're asked to find a formula for capital T, the unit tangent vector. So we're going to start with our r prime that we just figured out in the previous part, 10t minus 8t and 6t. And we need to find the magnitude of that vector, because capital T is r prime of t divided by the magnitude of r prime of t. So we already know that our r prime is 10t, negative 8t, 6t. The only question is, what's the magnitude of that vector? So we take the square root of the sum of the components squared. So that's going to be 100t squared plus 64t squared plus 36t squared. That's the square root of 200t squared. And we can simplify that to 10t radical 2. Simplifying our expression now, we're going to get 1 over the square root of 2, negative 4 over 5 times the square root of 2, and 3 divided by 5 times the square root of 2. So it turns out here the unit tangent vector is actually a constant, and that's our result. For this problem, we're given an expression for r prime, and we're asked to find a function that has that as its derivative and also has the property that r of 0 equals 1, 2, 3. So we're going to integrate. We're going to integrate r prime of t. That's the integral of 3t squared e to the minus t sine of 2t dt. Antiderivative of 3t squared is t cubed. Antiderivative of e to the minus t is minus e to the minus t. And antiderivative of sine of 2t is negative 1/2 cosine of 2t, plus some constant vector. Now we're going to use the fact that r of 0 is 1, 2, 3. So we plug 0 into our function. And set that equal to the vector 1, 2, 3. 0 cubed is 0. E to the 0 is 1, so we get minus 1. Cosine of 0 is 1, so we get negative 1/2, plus c equals 1, 2, 3. So that means that c equals 1, 3, and then 3 plus 1/2 is 7/2. So the function we're looking for is t cubed plus 1 minus e to the minus t plus 3, and then minus 1/2 cosine of 2t plus 7 over 2. Last one here. We've got a curve, again, given in vector form, and we want to set up but do not evaluate an integral to represent the length of this curve. And again, here we have to remember our formula, which is that the arc length is the integral from a to b of the magnitude of r prime of t with respect to t. In this case, r prime is the vector 2t, 3t squared. The magnitude of r prime is the square root of 2t squared plus 3t squared squared, which is 4t squared plus 9t to the fourth. And so that's going to give us the integral from 0 to 3 of that expression, 4t squared plus 9t to the fourth with respect to t.